Welcome to Chapter 1 of Hot Topics. In this particular Hot Topics, we'll look at all of the topics that we think you're most likely to have trouble with in Chapter 1 of ALEKS. And also, we name these topics based on Alex's name for each of the categories. So our first topic, as you'll see in a moment, is solving various types of equations, and I believe that's also what Alex calls this as well.
Well, we've actually blended a couple types in here,
okay.
Bill, as a helpful review. So the first one, let's go ahead and get started. The first equation that we have here is kind of an elementary algebra level, but we wanted to kind of review any of you that's been a while. So when you look at this equation, first of all, you'll notice we have a number and variable on each side. Typically, what teachers try to encourage you to do is bring the x's to the left side and the numbers to the right. In this case, that works out well because the x on the right side is smaller than that on the left. So if you recall, you want to add opposites to both sides. Now this one we'll take in steps. So that gives us 3x minus x is 2x. Carry down the 5 equals -7.
And again, let me just say one thing here. So notice on the right side of the equation there, they're adding x. It's a plus x. So Jerry did the opposite. Jerry subtracted x from both sides. You can do whatever you want to both sides as long as you do the opposite operation. If they're adding, you subtract. If they're subtracting, you add.
That's it. Now, our second step here is to move the 5. Now, since the 5 on the left side is being subtracted, you will do the opposite, which is add to both sides. So this gives you the new equation, 2x equals -2. Now your final step is to move the 2 off the x. So 2 is being multiplied by your x, so to undo that, you will divide both sides by 2, and that gives you the final answer of x equals -1. Okay, let's move on to the next one. This problem is one of the tougher ones from elementary algebra, but it's a good starter here in intermediate. This one involves parentheses as well as multiple terms on each side. So our first step is to get rid of those parentheses. Now you might recall that this involves the distributive property. So your first line actually looks like this. 4 times 2x is 8x. 4 times -1 is -4. Carry down the 3. Equals, and over here 5 times 2x is 10x, 5 times -1 is -5, and carry down the x. Now, before we start solving this, what you want to do is get all the terms on the left side combined and all the terms on the right-hand side combined to match that first problem that we've already worked so far. So, on the left side, you'll see that we have the -4 and the 3 and the 10x and the x. So we want to combine these and get this equation down to just 4 terms. So this becomes 8x minus 1, and on the right-hand side, 10x plus x is 11x.
Right, remember that x is the same as 1x, so 10x's plus 1x is 11x.
And you also notice we did not add opposites. We did not cross the equal to sign, so therefore you do not add opposites at this point.
Right, at this point we're just combining like terms on either side. Once we've gotten to the point we're at now, where we have a variable and a number on each side, that's when we start worrying about adding opposites to both sides.
Now, we're going to advance you a little bit in your algebra. This time I see that 8x is smaller than 11x, so instead of me bringing 11 to the left, I'm going to bring 8 to the right. I'm also, at the same time, going to bring the 5 to this side. There's no sense in doing 2 separate steps because we realize that most of you are going to be doing this all in one step. So that leads us to the following. Those cancel, so you have just a 4 on the left side. 11 minus 8 is 3, and then those cancel. So you're down to just 3x equals 4. Last step, clear this 3. To do so, you're going to divide both sides by 3, giving you the final answer of x is equal to 4/3. Okay?
All right, let's do some problems involving fractions because we know that these problems often throw students. So if you're watching the Hot Topics video, it may be because you hit these problems and you couldn't remember how to do them.
That's it. Fractions we know are not your friends, as we would like to say. However,
Jerry likes to say there are two bad words in algebra. One is fractions, and what's the other bad word?
Factoring.
Right, we'll get to factoring later on in these videos. Okay.
That's it. All right. The first thing we want to do when we have a problem like this is get rid of all the fractions. We know most of you don't like to work with them. So to get rid of them, we call it clearing the fractions. So to clear the fractions in this first problem, I want to find the common multiple of 3 and 5, which in this case is 15. And I'm going to multiply each term in the problem by 15.
So notice, to figure out what to multiply both sides by, Jerry just multiplied the two denominators together. 5 times 3 is 15. That's where it came from.
Yes. Now, the next step is the most critical. When you take 15 times a third, remember this is in the numerator, so the 3 goes into 15 5 times. Here nothing cancels because there was no denominator. Here we have another one, 5 into 15 3 times, and then again nothing here. So this will in essence eliminate all of our fractions, giving us the new equation of 5 times 1x is 5x, 15 times 5, 75, equals 3 times 2, 6x, and then 1 times 15 is 15. As you can see, our goal in every problem is to get it down to a variable and a number on the left and a variable and a number on the right, and then it's up to you. Once you get there, you should be able to finish the
Right,
problem.
once you get there, we expect you'll be home free.
So if you were looking ahead on this problem, you'll see the 5 is smaller than the 6, so I'm going to bring the x's to the right.
Right, Jerry doesn't like negative numbers, so Jerry's goal is always to make sure the x has a positive number next to it.
My students taught me that. Now, your new equation here becomes negative 90 equals x, and those cancel. And what's so nice, 6x minus 5 is 1, and we are finished with that one. Now, in our next one, you'll see that we have 3 denominators, and this time, a little bit more thought, but what is the common denominator, Bill, between 3, 4, and 2?
Well, the question I ask myself is, what's the first, I usually look at the largest number, 4, and I try to figure out what's the first multiple of 4 that 2 and 3 also divide into. 4 times 2 is 8. That's no good because 3 doesn't divide into 8. But 4 times 3 is 12. And 3 goes into 12, 4 goes into 12, and 2 goes into 12. So that's the easiest number to use to solve this equation. However, I will say that if you just multiplied all 3 numbers together, 4 times 2 times 3 is 24, you could multiply everything by 24, and although the numbers you'd have to deal with would be a little bit bigger, you should still get the same final answer. It wouldn't matter.
That's a great
But
point.
we'll go ahead and use 12.
We'll use 12, keep our numbers small here. So again, I'm going to take 12 times each term here.
Right, and notice that you multiply 12 by every term, not just the fractions. That's one of the most common mistakes that we see in these problems.
Yes, it is. Okay, now, when we cancel these out here, 3 goes into 12 4 times. 4 goes into 12 3 times. 2 goes into 12 6 times, and then of course there's nothing to cancel here. So here's our new equation. 4 times 2x is 8x. 3 times negative 1 is negative 3, equals 6 times 1x is 6x, and 2 times 12, 24.
Again, notice we're right back where we always want to end up. Variable number on one side, variable number on the other side.
Yes, this time I will take my x's to the left and my numbers to the right in order to avoid those
horrible
pesky
negative
negatives.
numbers, right?
So the 3, we're going to add it to both sides, and that gives us the new equation, 2x, those cancel, equals negative 24 plus 3 is negative 21, and then our last step, divide by 2, and we end up with x equals negative 21 halves. And you are allowed calculators in this course, and if your teacher so asked for it, that's negative 10.5.
And also, Alex will accept negative 10.5 as the answer as well. So if you want to change your answer to a decimal, usually that'll be fine.
As a matter of fact, your calculator in ALEX should be available for
That's
every
right.
single
Yes,
topic.
yeah, because there's also a calculator in Alex, which you should feel free to use if you want to.
Okay, one more, and we know this one
Yeah,
is
this
the
is the one that's
climax
the
of this
hardest.
chapter.
Yeah, this is tough.
First of all, when you notice the two denominators, they are simple, a 3 and a 2. So our least common multiple or least common denominator between the two of those is going to be a 6. Now, this is where you really have to be careful. Notice I am putting parentheses around the entire numerator. And I cannot forget that right side because that is a common mistake. Now, when we cancel this, you need to remember that this number 2 out here is going to end up multiplying by both terms in there. And on this one, it's going to be a 3. Over here, nothing cancels. So here's our new equation. 2 times 4x is 8x. 2 times 5 is 10. Now be careful. This is a minus 3. I'm going to actually slide the minus up there so you realize you're actually distributing a negative 3 times both terms. So that's going to give you negative 15x and then minus 6. And on the right side, we have negative 24.
Right, and that's the most common mistake we'll see. Students will multiply the 2 by the 4x, but then not multiply the 2 by the positive 5, and the same thing. However, if you don't make this mistake, then I'd be willing to say you're probably home free on this particular equation. That's a mistake that's usually that we're most likely to see.
That's it. Yeah, again, once you get to this point, we feel pretty comfortable that you're going to make it through the problem.
Right.
It's just getting to that point. So now, I'm going to combine like terms here before I go any further. And you'll notice this is how I teach on a board in a classroom. When I'm combining like terms, I just put lines underneath, not adding opposites, because we know we're not crossing that bridge right here, which does change the sign. So our new equation is actually 8 minus 15, which is negative 7x, 10 minus 6, which is 4, equals negative 24. Now, this problem does not have an x on this side, so we will leave the x as it is, even though it's a negative, and Bill knows I don't like negatives, but we will go ahead and move the 4 over. So that means we'll subtract 4, and that gives us negative 7x equals negative 28, and oh, what a nice number that is. Dividing both sides by negative 7, just be careful and watch those signs. You end up with x equals positive 4.
Which I believe is Jerry's favorite number, if I'm not mistaken.
It is one of my lucky numbers.
That's one of your
Pretty
lucky
good.
numbers, yeah.
All right. Well, that wraps up solving equations. We hope this has helped you out, and be sure to look on pages 25 through 30 in your textbook if you need some more examples. Have a good day.